problem number 3. In a convex polygon ABCDE, angles A, B, and C are congruent, and angles D and E are congruent. If the measure of angle A is 40 degrees less than the measure of angle D, what is the measure of angle D? Alright, well, this is a geometry problem, so I like to draw pictures first of all. So let's just draw this. It's a 5-sided polygon, right? So because we have 5 vertices, and so we're gonna have 5 sides. So let's draw something that this might look like. So you got 1, 2, 3, 4, 5. Okay. And we'll just label these vertices. I don't know that this is to scale. I'm just drawing something random here. And we'll label the vertices A, B, C, D, E. And so I'm going to assign some variables here because we know that A, B, and C are congruent, which means that they're the same angle, right? Those angles are the same. They're equal. So I am going to say, let's let x be the measure of A and B and C. And we'll let another variable y be the measure of D and E, right? Because we know that they are congruent as well. So, what does this next statement say? It says that the measure of angle A is 40 degrees less than the measure of angle D. Alright, so let's write that out. The measure of angle A is 40 degrees less than the measure of angle D. Okay, so x is equal to y minus 40. And that's all they give us, right? But we also know something based on the fact that this is a polygon, a 5-sided polygon. We know the sum of the angles in the 5-sided polygon. We don't know the individual angles, but one good thing to remember, I haven't got the sum of the angles of different polygons. I haven't got those memorized, but this is what I do have memorized, is that if you take this polygon, you can divide it up into triangles, and I know that the sum of the angles in a triangle is 180. Alright, so you can see that the triangle's vertices fall on the vertices of this polygon. So if you were to add the angles, this is 180, right? The sum of the angles is 180, right? This is, this angle is part of the polygon, and this one is, this angle is part of angle D, and this is part of angle A. So this is 180, this is 180, and this is 180, right? The sum of the angles in the triangles are 180. So I know that the sum of the angles in the pentagon, it's not a regular pentagon, but it's a pentagon, is 3 times 180. So let's do that. Let's take 180 times 3 gives us what? 24, 540 degrees. Alright, so I also know that 3x plus 2y is equal to 540. Okay, this is a good thing to remember. I would have trouble remembering all the angle measures of all the different polygons, but just remember that you can break a polygon into triangles. So if you have, this is a pentagon, you have 3 triangles that you can break it up into. If you have a hexagon, you'll have 4 triangles that you can break it up into. Alright? So, alright, well, we have x is equal to this, and then we have 3x plus 2y is equal to that. Let's just make a substitution. Let's just substitute right in here. We can substitute y minus 40 in for x. Alright? So 3 times y minus 40 is equal to 2y. Whoops, not equal to 2y. What am I saying? plus 2y, erase that, plus 2y is equal to 540. Alright, let me scroll down a bit. And so let's distribute the 3 inside the parentheses. So that gives me 3y minus 120 plus 2y is equal to 540. I can add the 3y and the 2y, and I'll get 5y. I'm just going to put it here, 5y. And then I'm going to add 120 to both sides. Okay, plus 120. So I get 5y is equal to 660. And if I divide 5 into 660, we get 1, we got 3, 15, and 2. So y, if I divide both sides by 5, y is equal to 132 degrees. And remember that y is the measure of angles D and E, which is what we want. So hey, look at that. We combined a little algebra, a little geometry, and there we go. The answer is 132 degrees.